In this video, we're going to conclude our three-statement projection model for Apple, and we're going to wrap up by filling in one of the last remaining items here, which is what happens in terms of the interest income and interest expense over these 5 years, from 2010 through 2014. Now, just to recap what we've done so far, in the previous videos, we started out by looking at some basic assumptions for Apple's income statement, and then used those to create projections, which you see right here. And then we moved on to some of the balance sheet items and creating projected percentages for those. Then we got into the business of actually tying together the statements, actually putting numbers to these percentages, and then finally linking everything together and making sure that the individual items on the cash flow statement and balance sheet were reflected on the respective statements. One of the last remaining holes that we just filled in was figuring out what happened with intangible assets and the amortization of intangibles. So now the only remaining thing to do here is to figure out what's going on with the interest rates to Apple. So the first thing that we need to decide here is what the cash and debt interest rates are. And the way this works is pretty simple. For cash interest rates, we want to look at the average cash balance over the course of a year. And then for debt interest rates, we want to look at the average debt balance over the course of a year, and then assign some kind of interest rate to that, and then use that to figure out what the interest income or interest expense was that year. So first off, to get these numbers historically, the best place to look is in Apple's own filings. So I'm going to go to their 10K right now, which is linked to right below this video. And I'm going to press Control F to do a search for interest rate. And here we see it's actually the first thing we come to right under this heading, Other Income and Expense. I want you to draw your attention to the first paragraph, the second to last line of the first paragraph. The weighted average interest rate earned by the company on its cash, cash equivalents, and marketable securities was 1.43%, 3.44%, and 5.27% during 2009, 2008, and 2007. So let's go in and enter these numbers now. So we have 5.27, 3.44, and 1.43. Now for the debt interest rates, remember that Apple has never carried debt historically, at least in recent history, so we're just going to enter 0% for these. So we have these numbers historically. Now to figure out what the projections on these look like, what we would actually do at an investment bank for the cash interest rates, we would look at something called a LIBOR curve or an interest rate curve on Bloomberg or another source, and we would look at what economists are actually projecting and predicting as interest rates over the next few years and use that as the basis for this. In our case, we don't have access to that information, so we're going to make our own projections here instead. For the debt interest rate, typically what we would do here is, again, look at the LIBOR curve and look at current debt issuances from similar companies, similar size debt, and we would use those to assess what the debt interest rate might be. In this case, once again, we do not have that information, so we are going to make our own projections for both of these. So for the cash interest rate, we're going to go with 1%, 1% for 2010 and 2011, going up to 2% in 2012 and 2013, and then 3% in 2014. And this corresponds to the general economic sentiment at the time, which is that 2009, 2010, the economy was getting better, but we were in store for a very slow recovery there. For the debt interest rate, I'm going to go with 9% here. And what I'm going to do is also link this to the 2010 number and take this all the way across. So here we're assuming that the debt interest rate is staying constant for all 5 years. Given the type of debt that we have where we're not assuming any principal repayments, we're assuming that it stays the same on the balance sheet. This is a fine assumption to make. Usually debt like that has higher interest rates, so debt where you repay some of the principal might have an interest rate of 5, 6, 7%, somewhere in that range. But debt that stays on the balance sheet, since you don't have to repay principal, the lenders want a higher interest rate in exchange for that. So that's why you see 9% here versus some of the lower interest rates that you might ordinarily expect on debt. So we have those in place, and now what we have to do is go down to the income statement and actually fill in these numbers. So for the interest income, what we're going to do is take the average of the 2009 and 2010 cash balances. So I'm going to sum up the 2009 numbers, cash and cash equivalents, short-term securities, and then long-term securities. And then I'm going to take the sum for the 2010 numbers, cash, short-term securities, and long-term securities. Now I will multiply this by our effective cash interest rate. Control C and copy this across with Alt ESF. For the interest expense, we're going to do the same thing, but the sign will be the opposite here because it's an expense, not income. So I'm going to take the negative average of the debt balances for 2009 and 2010 here. 2009, 2010. We're going to multiply this by our assumed interest rate of 9% right here. So we have that in place. Copy this across with Alt ESF. Then for other income and expense, I'm going to enter 0 here, and I'm actually going to assume that this stays at 0 going all the way across. The reason is because these are typically one-time expenses and charges that are very difficult to predict, very similar to some of the items that we saw in cash flow from investing and cash flow from financing on the cash flow statement. I'm also going to change the formatting here to black for these because these are formulas rather than hard-coded numbers. And so with that in place, our model here is pretty much complete now. One thing we also want to do here is check some of our formulas to make sure everything is working correctly. So this interest income seems a little low because it's falling by around 50% from the 2009 level right here. So if I press F2, we see that I've actually set up the formula incorrectly. It should be I-69 plus I-70 plus I-78 right here. Copy this across with Alt ESF. And now that looks much better. That looks much closer to what we were expecting for the interest income in this case, because it stays about the same level as the 2009 and even before that, the 2008 and 2007 levels, at least in the first 2 years here. So that's how we finish tying together the three statements and how we calculate the interest income and expense based on Apple's cash and debt balances over these 5 years. One other quick point I want to make here is that if you go to Alt-TO for options and go to formulas, you remember that in the first video I told you to turn on automatic workbook calculation and also to enable iterative calculations, and this is exactly why. If you look at these formulas, the interest income formula is circular because it depends on the beginning and ending cash balances. Well, if you think about it, the ending cash balance here depends on what the interest income was, because if the company earned more from its interest, then it's going to have more cash at the end. If it earned less from its interest, less on its cash, then it's going to have less of a cash balance at the end. So these calculations are inherently circular. There are a couple ways you could do this. If you wanted to get rid of that altogether, you could just look at the beginning cash and beginning debt balances, for example. But typically in investment banking and financial models like this, you assume some kind of average, and sometimes you build in the capability into your model to look at only the beginning number or to look at the average as we've done here. So there are a couple of ways to address it, but be aware that it's very common to use the average function for both cash and debt interest, and that if you do that, it's going to create a circular reference in your model, and you're going to have to deal with that by changing around your Excel settings. So that's pretty much it for our overview of the three statements and how you make a projection like this for Apple. Now that we've covered this, what I want to do next is go into a few different related topics on three-statement projection models as we have right here. First, I'm going to show you a little bit more about deferred tax liabilities and how those work in the context of this type of model. And then I'm going to go into some examples of how to fix your model when it's broken, when the balance sheet doesn't balance. And then we're going to conclude by looking at some possible interview questions you might get on this topic of how to create three-statement projection models in the context of investment banking and private equity interviews.